Okay, thanks. I'm Jeff Freymueller, and I'm standing in for Glenn Mattioli, who is something, I think he's around the summit of Erebus volcano in Antarctica or something exciting like that. So I'm going to talk about the future of the Plate Boundary Observatory in the GAGE facility and beyond on Glenn's behalf. First of all, let me just briefly say a little bit about what UNAVCO is. It was formed 30 years ago as a facility to provide shared equipment, GPS receivers, to the research community. And it's, for the last approximately 15 years, UNAVCO Inc. has been a nonprofit corporation. So it's a community effort, Geosciences community effort, governance provided through the university and other institutional members. The funding is primarily from NSF. That's long provided the core support, as well as now also, I think, some NASA funding for the core support, and then project funding and so on. Really the goal is to enable researchers to do more work in geosciences using geodetic techniques. And UNAVCO built and operated the geodetic component of EarthScope. So EarthScope should be familiar to most people, I think. Let me just briefly mention a few points. It's an NSF project funded under the Major Research Equipment Facilities Construction account. It started in 2003. It has a commitment through 2018 from NSF. The first 5 years was a construction phase, and then it's been an operation phase. So for the geodetic part, PBO, it was built out over 2004 to 2008, and then has been operated since that time. EarthScope also had a component of drilling into the San Andreas Fault, and also a seismic component, US Array, which is also still active. EarthScope, interesting, was Popular Science called it the #1 most epic project in the universe among big science, so we can't really beat that, I guess. Anyway, so it's a 15-year project designed to sunset in that time. What PBO mostly consists of is a network of high-precision GPS sites. There's also a couple other components, but I'm going to talk here mostly about the GPS. So over time, those instruments, many of them have been upgraded to provide real-time data. Some of them also provide meteorological and other data as well. So the science that motivated EarthScope was solid Earth science, but from the beginning, these instruments provide a lot of other capabilities. So GPS is an atmospheric sensor, it's an ionospheric sensor, it's a water, potentially soil moisture and vegetation sensor. We didn't realize it was that until Christine Larson recognized you could do that. It's actually a hydrology sensor, at least if the water, at the lengths or at the scale at which water actually weighs down the surface of the Earth's crust. It's a cryospheric sensor. So it's a multidisciplinary sensor from the beginning, and a tremendous amount of EarthScope science has actually used some of these these things that were not envisioned at the beginning in the project. So very much an integrative and multidisciplinary project. So UNAVCO, in addition to EarthScope, has also some other sort of projects. I'm not going to go into the details of those, but again, it supports individual PIs as well as large networks and so on. One of those is Coconut. I think John Brown is going to mention that in the next talk. So one change that happened recently for UNAVCO in all of this is the beginning of what's called the GAGE facility. I think I've got this right, Geodesy, Advancing Geosciences in EarthScope. The key decision that NSF made was, rather than having a separate facility and an EarthScope program, to really integrate these completely. And so rather than having two sort of parallel things, one which were funded through slightly different paths, to actually merge them together. So there's a single facility. There was a plan for doing that. I think we all know the sort of then there were budget cuts scenario. We've all played that particular tune and heard it many times. Anyway, so UNAVCO convened a workshop, NSF-sponsored workshop, to provide some community guidance on the future of the GAGE facility. What needs to be done in terms of operation, that should say 2018, not 2015. Are there any operational changes needed? And how do we look into the long-term sustainability? So let me just give you one example of that. This is the South Napa earthquake earlier this year. Relatively small as earthquakes go. I'm from Alaska, so magnitude 6 earthquakes don't really seem like all that much, but if they happen in your neighborhood, it's a pretty big deal. And And so these are sites of the PBO that were downloaded. The green is sites that were fully downloaded high-rate data from this earthquake. And this just shows an example, a few examples of what came out of that. So this is the static displacements after everything was done and the ground shaking was done. Static displacements from the earthquake. The star is the location. All the arrows show the direction and magnitude of permanent motion here. We've got a scale, I think that's 12 millimeters here, so we're looking at about a half an inch for that sort of scale. So relatively subtle motions, but easily within the measurement precision of GPS. This just illustrates for a couple of sites what those little offsets look like. These are 5-minute solutions. So essentially the earthquake is a small one, all happened within 5 minutes. So you see from one point to the next just a jump. On the other hand, if you look at the earthquake at higher rate, 1 second sampling, and this is from the same instruments, but just looking at the higher data rate, you see this is actually the borehole instruments, but you would see essentially a seismogram from the GPS as well. All right, so one of the things that is developed here is that PBO is actually now viewed as a utility by many stakeholders beyond the university committee. Just one example of this is that earthquake early warning systems that are under development for the West Coast and other places plan to use these GPS instruments, real-time data from these GPS instruments to help detect and in particular detect when earthquakes are particularly large and do this in real time. So it's a piece of infrastructure. On the other hand, this is all presently built on the back of a 15-year research program, which is supposed to come to an end in 3 or 4 years. So how do we go beyond this and go to the sustainability? NSF has made a huge investment in this. USGS has made an investment in parallel in GPS networks and other things. And so how do we actually make something work going forward and not lose this fabulous capability that has been built, but actually sustain it and build on it? So we convened this workshop, and in addition to these scientific and hazards-oriented things, there's additional stakeholders in the atmospheric community, but also in the land surveying community. So land surveyors use GPS to do their job faster and more efficiently, and they want real-time data from GPS networks. They want dense GPS networks in real time. Not because they're interested in deformation of the ground or earthquakes, but because that lets them do their job faster. So it's an efficiency issue. And we want to be able to look forward to how to make this sort of infrastructure sustainable for all of the users and not just for the ones who, the NSF, for example, who originally put the money in, but have some sort of larger partnership. So there were some immediate actions. And the only ones I'll even mention at all are in red. I think the news from the workshop was that up to 2018, PBO is in pretty good shape. There will almost certainly be some loss of data recovery. PBO has operated at a very, very high level of data recovery, very high fraction. It's very difficult to avoid losing some of that, but fundamentally we should still be maintaining the capability. We want to seek partnerships to look at other issues. So this may be earthquake early warning, this may be atmospheric sensing, this may be, again, land survey and other information, geospatial information applications. Many of those applications require the data to be available in real time. And so that means it takes a new investment actually to take a non-real-time station and put it in real time. And so we want to expand this real time, and also what many users actually want, not just GPS, but they want GLONASS and Galileo, all of the other global navigation satellite systems. They want all of these. Right now, most of PBO is GPS only. So we need to work and develop some pilot projects to position PBO for the future to be able to fulfill the needs of all these other users as well. And I guess that's all. So I'll just go back to the last slide here, and I guess it stops when you're done. You can just hit play, and we can just leave that up if there's any questions. It looks like we have 18 seconds.
18 seconds. Anyone have a question? We'll take one question.
Well, actually, I guess we're still green, so we might have even more. But
no, you only have 10.
Okay, we have 10 seconds. All right, no questions. So.
All right. Thank you very much.
Thanks. Thanks.